Hello, everyone, and welcome to our session today. My name is Yarden, and together with Moria, we're managing the Reactor program. About the Reactor, for those of you who might don't know, Microsoft Reactors are hubs for technical learning and sharing when students, developers, and startups connect globally or with the local community. If you're looking to dive into AI or the latest technology, the Reactor is the place for you. We have 10 reactors worldwide when you can find all kind of events, live stream, workshops, and anything you like. You are welcome to scan the QR code that's now on the screen to join our newsletter and get information about the newest events and everything in your region. We will also share the links in the chat. A little bit about Microsoft Learn for those who don't know it. It's a hub for developers for learning and training. Elevate your career and your development journey. It's all for free and you have all kinds of topics you can learn about. One of them is our AI Learning Hub. You can actually go inside the Learning Hub and explore all kinds of AI learning paths, power the AI transformation, and be on top of everything new. You can go ahead and scan the QR code to join and start your own AI journey. So today we're on the session about generative AI. You can scan the QR code to see the previous session if you missed it, or just follow up and register for the future ones. A little bit about Q&A. You are welcome to write any questions you have during the session in the comments. In the end, we will answer them all, and we also have Bethany that will be monitoring the chat and answer your questions. This event is recorded, and you will receive the recording after the event and can visit it on our YouTube channel. So a little bit about code of contacts. Please be aware of others, welcoming and respectful and friendly and patient. We're open to all of your questions. And from here, I will give it to you, Bethany. Thank you very much.
Thank you. Thank you so much. As you've heard from Yaden, this is a series of events. And for all the participants who are from Kenya, you will get a chance to earn yourself a voucher at the end. So every link that you might need will be in the blog post that Yaden will drop in the chat, whereby the first thing is this is where you are, the Reactor sessions. And this is the fourth session in our series of events. We have these sessions every Tuesday and Thursday right here at the Reactors channel. You can register and RSVP to make sure you don't miss any of the sessions. Next, we have a Cloud Skills Challenge where you can participate and be able to see yourself on the leaderboard and learn alongside the videos. As for the participants from Kenya, you can request a voucher using this link once you're done with the challenge and you've been able to attend the entire series. To engage with other learners, we have a Discord channel you can join. We have the Discord for the Azure AI global Discord, but we have a specific channel for this challenge. So if you click on this link, it will lead you directly to our Discord channel. And then once you're done with the events and you need to learn more, you need to grow your skills in AI, we have the links right here. One to the AI Skills Navigator, which helps you try and understand what you should learn next and how you can get started in the next steps of AI. And then the learning collection with all the links I've mentioned here, as well as additional learning content to prepare for the AI 900 exam. And with that, I've talked about a lot of links, so make sure you go to the blog post and check it out. The link will already be dropped in the chat. If you want to learn more about the calendar, the events, and everything else, you'll find them on this blog post. And with that, I want to invite our speaker for the day. And our speaker will be Julia Mwiruri, who's my fellow cloud advocate here at Microsoft. And I think we're now almost clocking 3 years at Microsoft, if I'm not wrong. We joined Microsoft back in 2022, and we've been working together. She's from the JavaScript team, I am from the AI team. So we've been collaborating a lot together over the past few years. And she will be doing the first session of the generative AI section of this series, where she'll be building up on the fundamentals of generative AI. And then next week, I'll come back and talk about how you can leverage on the fundamentals she's talked about and build using Azure AI Foundry. So over to you, Julia.
Yeah, thank you so much, Bethany. I'm really honored to be here on this stream today. Yeah, so everyone, as you've heard, my name is Julia. I'm a colleague of Bethany. I work at Microsoft as a cloud developer advocate, and I'm really excited to be on this stream with you all. So today's session is basically going to be a gentle introduction to generative AI. I know 2024 had a lot to offer when it came to LLMs. And so in case this passed you, we're going to take this chance to just briefly go through the different concepts. So we're going to kick it off by, learning some essential things that you'll need to know when you start interacting with large language models. We are also going to define some terminologies and some concepts that you may have already heard about. We're also going to talk about some key best practices to have in mind as you're interacting with these systems. And then we're also going to briefly look at what you should consider when you're designing Gen AI solutions. And as we do all this, kindly invite you all to drop in your questions, your learnings, your opinions on the chat. We'll be happy to take them as we proceed. I believe we may have a few minutes towards the end to take some questions live. But as we proceed, don't hold back. Just give any question that you have on the chat, and Bethany will be helping me in answering some of these questions. So let's get into it. We have quite a lot to cover. I'll try and move at a reasonable pace and ensure that we all move together. So the first thing that we're going to do is to simply describe what an LLM means, right? So an LLM simply stands for large language model. And the by the book definition of what this is that it's a deep neural network that is trained on a large amount of data to an extent that it's able to perform various tasks using natural language. So that's a mouthful. That's quite a lot about what this is, but let's look at it in a different perspective. So one, it's a model. Think of it as a model that has just been exposed to so much data. It has been given so much data. So think of what I have in my knowledge base, what you know, what someone else knows. That repository is called the internet. And then you basically just take that and feed it into a model. So this model is pretty knowledgeable. And all this model does is, given how much it knows, it's simply able to make predictions when you give it any form of input. So in other words, when you're interacting with a large language model, the moment you give it an input, it could be a question, it could be some information that you've given it. It's basically just looking back through its training data and trying to predict what will come next. So that is basically all that works, all that happens when you're working with a large language model. So you may be wondering exactly how large are these models? And the answer to that is that this varies from one model to the other. And so I'm going to quickly switch over to my browser. So I'm just going to try and demonstrate most of these concepts, as many of them as I can. So the first link we're going to look at is GitHub models. And I'll ask the moderators to maybe drop this on the chat for me. So it's a link to GitHub models, github.com/marketplace, and you'll be able to access the models. Now, once you come in here, you'll see a list of available large language models. And some of them, just by the naming convention, actually mention the size of the model. So for example, let's have a look at this one from Meta. So it's the Llama model. It's version 3. And then we have the 8B instruct. So this 8B, and I'll click on it to actually just load some bit of information about the model. This is actually the size of the parameters that were used to train this particular model. So for a quick way for you to understand, exactly how large are these models, as I said, this vary from one model to the other. This one specifically that we're looking at is an 8 billion parameter model. So you can imagine how large it is, and you can just simply scroll down to learn more about this. If you're wondering about this page that we are currently on, this is called GitHub Models. So the idea here is that before you even, if you want to interact with these large language models, you don't want to go through the whole hassle of signing up on Azure, getting an Azure subscription. You can easily find these models as long as you have a GitHub account. You can easily find these models on GitHub. You can play around with the models. You'll see that in today's demo, and then you can basically just see how they perform. So that's a quick way to understand exactly how large these models are. I hope that makes sense. So the next thing that we're going to do is that we're going to now start at the very beginning. So my intention with this session is to sort of take you on a journey. So we've learned what LLMs are. Let's look at how you can train one, how you can use one for your different use cases, and basically we'll build it up all the way to how you can deploy these models and use them in production-ready applications. So the next order of business is understanding how exactly do you train these models? How can you create an LLM? And as I mentioned earlier, the whole idea here is you taking a bunch of information. So you grab as much data as possible, could be from the web, could be from social forums, from books, or from code repositories. And then you take all this information and you basically just feed this into a model and train it for it to learn from this data. Now, as a result of this process, you get what we call a fundamental or a base model. These are the likes of GPTs, the Phi family, DALI family. So you're basically getting a fundamental model that is able to just perform the basic functionality of a large language model. However, something to note is that this is a pretty expensive process. So there's a reason why not everyone is training large language models. So if you are considering building a Gen AI system, probably you might consider already building on top of the existing language models. Now, the next thing that you might consider doing is instead of taking this first step of training a large language model, you can basically take a pre-trained model and then bring in your own domain-specific knowledge to further train it, and you'll end up with a model that has more weights on your specific industry. So let's use an example for this, and this process is called fine-tuning. So imagine you work in the medical industry. In this scenario, you don't need a large language model that knows everything about everything, but rather you want to work with a model that knows everything about medicine. So to achieve that, you can take in a base model and then come in with your medical related data and then retrain that model. And then what you will end up having is a fine-tuned LLM that has more weights on the medical training data set that you provided it with. So that's simply the process of fine-tuning a model. Again, it's cheaper if you were to compare this to building a language model from scratch, but it's also pretty fairly expensive. So that's also something else to have in mind. Then the last thing, so if you also want to take that further step and improve the quality of the results from this LLM, you can take a certain approach, which is having now humans come in to ask questions to this LLM. You take in the answers that they get, you evaluate these answers manually, and then you get to see if the LLM is performing as it should. If it doesn't, you go back to the training parameters, make your adjustments until finally you end up with your desired model. So this is an approach that we are calling reinforcement learning from human feedback. So that's the extra step that you can take just to ensure that you're ending up with a result of an LLM that basically just performs exactly as you want it to. And this is what you actually use to build your Gen AI applications with this as your backend. So I hope in terms of how you get to train these models, I hope that makes sense. But again, we're going to break this down even further to see how this kind of works in the applications that you'll be building. So the next thing we're going to do is to now take a step further and understand how do these language models work, okay? And for a typical text generation model, okay, if you look at what is on the screen right now, you will see that the first thing is that this model will take in a natural language input. So think of when you're using ChatGPT, you just give it your input, in most cases in natural language. And then this input is going to be broken down or split into smaller units, which we are calling tokens, right? And you can see them here. They are depicted by these colors that you can see on the screen. So these tokens are basically just a sequence of characters. They're not necessarily words, they're not letters, but it's just a way for the model to just, break down this input that you've given it for it to process that. And then before these tokens are sent to the model itself, we have a process called embedding that happens here, where these tokens are converted into their numerical representation. So why is that important? Remember, this natural language input that you're giving the computer, you and I can understand that, but the computer and the model only understands numbers. So we have that additional step where before the input gets to the model, the tokens are going to be converted into their numerical representation. Then the model will process that. And as output, this model is going to give you a probability distribution list. This is a list of the likely tokens that will come after what you've given it. So remember at the very beginning, I mentioned that language models simply just take in input and then they try and guess what should come after what the user's given me. So in this case, the model will spit out a probability list of the tokens that should come in. And then now based on the parameters that you set, it's going to select the most likely token in your particular context. If this is a lot, kindly bear with me, but I'll show more in depth of how this actually works. So if you want to understand more about tokens, we are going to talk more a little bit about that, because this is something that you'll likely hear a lot. When you're designing GenAI applications, this is actually the currency. This is how much if you want to know how much you'll be spending, you'll be dealing a lot with the number of tokens that you'll be allowing for your solutions. So as I mentioned, LLMs don't directly use that text you provide. They will work with the token. So the text is broken down into tokens. And that process, we call it tokenization. And if you want to actually understand more how this works, I'm going to switch back to my browser. And you can switch over to the OpenAI platform. So the link is platform.openai.com/tokenizer. And then you can basically just come in here to see how the different models from OpenAI actually perform this step. So if you were to just add in some text, let's say this is a really nice session as an example. So you can see that this statement has 29 characters and it has been split into 6 tokens. You can see how they have been subdivided. The token in most cases will also include, like the space between the word. It's also going to include any punctuation marks that you use. And this also varies from model to model. So if you were to clear this, and then let's just use the example that OpenAI provides, you'll see that if you're using GPT-4o and 4o mini, this block of information here translates to 53 tokens. But if you're using a different model, you find that the number of tokens changes. The same thing if you're using, say, the GPT legacy model. So it's good to note that these tokens, the calculation of tokens varies from model to model, and they also vary from language to language, right? So that's just a good thing to know. If you want to play around with how tokenization works, you can visit this site and just get to see how the different processes actually happen. So I'll go back to my slide. And you can see here we have an example. So assuming you're working on GitHub Copilot, and you give GitHub Copilot a function like this one, this is how it's actually going to be translated for GitHub Copilot, which is a tool that is powered by an LLM. This is how it's going to be translated into tokens. And then in the next slide, you can actually see that these tokens then get converted into their numerical representation. So now this is kind of what the model will understand. So an example is you'll see for the word function, that will get translated to 1723. And every single model has been trained on its own vocabulary of tokens. So that's the other thing to mention. And as I mentioned earlier, a key thing to note is that these tokens vary by language. So if you deploy a system and you have users, say, based in Kenya, you have other users based in Korea, the consumption from the two markets will actually be different, simply because this tokenization works differently for different languages. So I hope that makes sense. So we're going to now talk about some limitations, okay? So we've seen the importance of tokens and how they're calculated, but we have some limits. And the first one is the number of tokens that can go into a model, okay? So these models, most of these models, and we have proprietary models, we have open source models, most of these models are quite performant. And so the real power of these models lies in how much input can go into the model. So remember, another thing Large language models do not have any memory. So when you're interacting with an LLM, say ChatGPT for instance, it doesn't have any memory. It doesn't store whatever you're giving it into the memory, but rather it's taking in whatever you have in your chat session. So that is what it's actually working with. And so this actually brings us to the realization that these models can only work as well as the input that goes into the model. So given that scenario, you might have seen, like models that have a similar naming convention. So again, I will just switch over to my browser. I will go back to the GitHub models. I will switch back to models. And then you see this is a popular naming convention with the models from Microsoft, for instance. So if you filter down to the models that are provided from Microsoft, we have the 5 family. You're going to see that in brackets, just after the model name, you're going to see in brackets 128K or 4K, in this case 8K. So this number basically represents the number of tokens that can actually go in as input to the model. So this is how you also understand, what model should I use? Of course, more tokens mean that you'll be using more compute, which in the long run may be more expensive for you. So depending on the scenario that you're working with, this is how you can easily determine what's the context window, and the context window is basically what we are referring to as the input to this particular model. So again, if I go back to my slides, the other thing that I wanted to mention here is that the less context you use with an LLM, the more attention you get, which means the more accurate its output is going to be. So if you end up giving an LLM too much information, it kind of gets distracted in the midst of everything that is happening, and it might not give you a very accurate response. So it's good to note that you need to find a way as a developer. The moment I start interacting with your system that is LLM powered, you need to find a way to take in the input that I give it. Remember, you have almost zero control over the over the kind of input that I'm going to give this system. So you need to find a way in between my input and the backend to fine tune and to just create a prompt that will actually make sense to this particular model. So this brings us to the big question that the designers are asking themselves. So if this model can't take in everything, then what can it take? Okay. If you shouldn't feed it with all the information, what information are you supposed to feed into these models to get a more accurate response? And so that will bring us to the concept of prompt engineering. So up to this point, I know I've shared so much. So let me just see if we have any questions on the chat. I know Bethany is trying to take them as you share. But you can just keep dropping your questions on the chat. So far, I don't see any question. But yeah, this brings us to the concept of prompt engineering, which again, the by the book definition is that this is the process of designing and optimizing prompts to better utilize AI models. Okay, so that's basically how you can think of prompt engineering. Is as a user, whenever I pick up my phone to interact with ChatGPT, you almost have no control over the kind of question I ask it. But then remember, for me to get the best answer, and as a user, I don't care about this, but for you as the developer who's implementing this system, you need to understand, how do you actually take in the user input, modify it to ensure that you're giving this model very clear instructions. So when you're talking about prompt engineering, I'm going to briefly mention some few techniques because you're going to hear about this. So the first technique when it comes to prompt engineering is called zero shot. So this basically is you trusting that the model is knowledgeable enough to give you the correct answer to the question that you have. Take this as an example. You are working with an LLM and you simply tell it, translate the following text in French, hello world. And you trust that with the training data set that was passed into this model, it will have enough knowledge to give me a reasonable output. And as you can see here, the model will give you a fairly accurate response. That's zero shot approach. But then you may decide, instead of just trusting that the model knows how I want it to respond, you can choose to give it some few examples. Now, this is called few-shot learning, where the model is basically just going to learn from a set of examples that you give it. So in this case, you can see that we are not even giving it an exact question. So we are not telling it to identify the language that we're using, but rather we're just giving it a list of examples. So in this case, we have text, and then we have a semicolon, and then we have the language in which the text is in. So we've given it 3 examples, and then we have now the question that we're asking it. And you can see the output is that it basically understands the pattern that you're using in these examples, and it's able to come up with the next likely token. All right, so this is particularly useful when you want to have an LLM give you a very specific format. So you can definitely use this approach if that is what you kind of want from these models. Then the last one, which I think is pretty interesting, and again, the moderators can share this link with you on the chat. So there's an article that was published about what we learned about LLMs in 2024. And one of them was actually a very interesting realization. So when I was a young girl, just growing up, I remember when I was coming home with my assignments, in most cases, they were math assignments. I would come back to my assignment, I would try and attempt a question, but I would get it wrong. But then my mom would tell me, Julia, I need you to be keen, focus on the question, read through the question again. And I would do that, but the question that I would ask myself is, it's still the same me. I still have the same level of understanding and knowledge. It's still the same question. So what makes you think that if I pay attention to this question again, I will actually get it right? But to my surprise, the moment you start digging deeper into just the same question, you end up getting the right answer. And this is kind of the biggest, like a big realization or a learning point from what we learned about LLMs in 2024. The trick being that if you get a model to talk out loud about a problem that it's trying to solve, if you get it to break down the steps that it's taking to solve a problem, it will often get the results which this model would not have achieved otherwise. So in this case, as you can see on the screen, this is the third approach called chain of thought. So the idea is if you give a model such a question, the first attempt to see it got it wrong. But then if you introduce this last statement, so you tell this model, this is the same question, but now let's think about it step by step. And then in this case, we'll see that it's actually going to break down. So it's going to say, okay, when I was 6 years old, your sister was twice your age. This means your sister was 6 times 2. It's going to get 12. So at any given time, your age difference is 12 minus 6. And then now, since you're 30 years old, that means your sister is 30 plus 6. And now it actually gets it correctly. So if you can find a way to take in whatever input your users give to the system, and then augment that in the backend and ensure that whatever ends up getting into the model is clear, is concise. That's how you actually ensure that you're getting more accurate responses from these models. Okay, I hope that makes sense. So this will bring us to some key components of a prompt. So again, this prompt is the input that is going into the model. So you might have heard of a system prompt in some cases. So the system prompt is basically just some instructions, some further instructions that you give the model. So as a user interacting with your system, of course, there's that question that I will send to the model. But again, there are some guardrails and some instructions that you actually configure this model to use. So let me just give an example before we proceed with these slides. Again, I will go back on my browser. As you can see how I'm interacting with GitHub models, it's really just a quick way for you to interact with LLMs, get to see how they work. So if you haven't had a chance yet, if you want to just have this quick interaction with large language models, before you worry about signing up for any cloud provider, I would recommend you check this out. So in this case, what I'm going to do is that I'm going to, let me just get models from all providers. Specifically, let me work with GPT-4o for this part of the demo. So once you learn more about this model, the training data set that it was trained on the cutting of dates, you can open this playground. And once you open the playground, this will give you a chat interface. And I hope this is clear enough for everyone. This should give you a chat interface that you can now start interacting with the model. So for example, I will ask the model to explain the basics of machine learning. So the model will take some time, and then basically what I expect is for it to give me an answer based on the question that I have given it. So this is proving to take some bit of time, and I see the reason is because it's really coming up with a very long description for me. So it's basically just giving me, a description of machine learning, key concepts, types. So you can see it's like just giving me a whole lesson around machine learning. But what if that is not the behavior that I want from this model? So right here on the parameters, you can switch over to the right where you have the details of the model. You can select the parameters, and then right here we have what we're calling a system prompt. And what you can do here is, and I'm going to add a system prompt here. So I'm going to give this model some instructions. And my instruction is, you are a helpful assistant who loves using emojis and keeps your responses short and precise. So I will do that, and then I'm going to clear this playground, and I will ask the exact question again. So this way, I expect to see a slightly different response just because I have changed the system prompt. So this is how powerful the system prompt is. This is where you actually set up some basic instructions that you want the model to follow. If I go back to my slides, you'll see that this system prompt often has several key components. So the first one is the task. You want to give this model a goal. In this case, you're telling it specifically, I want you to act as an AI agent for blah, blah, blah. So this is where you give it a very specific goal. And then number two, we have the response grounding. So in case you want this model to base its response on specific data or on specific documents, this is where you pass in that particular instruction. And as you can see here, we're telling it to ensure that whenever it's giving the user a response, it needs to reference the factual statements. So it needs to cite where exactly in the documents or in the internet it got this answer. And I know that in most cases when you're working with, especially Microsoft Copilot, if you ask it for some questions and if it gets the answer from the internet, it's basically going to link you to the exact source just to ensure that it's giving you some factual information. And then this is also where you set up the tone. So if you want it to be arrogant, if you want it to be polite, professional, you set up the tone here. If you want to also add some safety guardrails. So for instance, if you want to tell the model to decline any requests to, maybe abuse a certain group of people, this is where you set those guardrails. And then of course, this is where you actually set in your settings for jailbreaks detection. So if the system actually gets a user who's trying to break its own rules, it can actually also decline such asks. So you can see in this case, the user will come in with a question, and the answer that you basically get will follow the instructions that have been set in the system prompt. So that's basically a part of the system prompt. But what I want us to focus more is on this grounding response, okay? So in some cases, you find that, and for most of the models actually are trained on data up to a certain time frame. So for instance, you'll find a model that says it has been trained on data up to the year 2023. Or you have data that is trained up to December of 2024, for instance. But for the systems that you'll be implementing, in most cases, you'll be having questions about real-time data. So that's a challenge, right? How do you get systems that can actually reference up-to-date information? Then the other thing is that the other challenge that we have is that unlike fine-tuning where you have to come in and retrain the model, you also need a way to add in your relevant documents to have the model or the system actually reference that. So in this particular set of instructions, what we're calling the response grounding, you see that we are telling this particular system to reference whichever documents it's using. So think of a scenario where you just got into a company and this organization has its own business documents, let's say documentation on how you can access your benefits information. So this is not information that is publicly available. So you need to find a way to grant this particular app that you're building access to your internal documents. And so that brings us to the last concept that we are going to talk about today, which is retrieval augmented generation, or RAG for short. So up to this point, again, I'm just going to pause and have a look at the chat, see if we have any questions. So I see a question from Bonsol. I hope I pronounced your name correctly. How do you estimate token usage? Perfect. So how do you estimate token usage? So basically, this would actually bring us to a different component when you're building a system. So if, let's say, you're using a tool like API management, we have some Gen AI capabilities that can allow you to basically set token limits per API call. So remember, how you're interacting with these models is through a set of APIs. And so you can basically set, if you're using API management, there's a way you can actually configure new policies, and it will be able to just cap the number of tokens that a particular user can actually use in the calls that they make to the model. So that's one way that you can do that estimation. But then the second thing that you can actually do is, when you're working with these particular models, you can set a token limit. And I think for that, I will just go back to GitHub models. Okay. So you can see right here on the parameters, apart from the one that is on max tokens. So basically, this is the maximum number of tokens that you will, either in this session or in part 2 of this session. But yeah, just a direct answer to that question is that you can set up the maximum tokens. As you can see, you can reduce them as you see. So do I sorry, Morgan, I think, could you try and rephrase the question? Morgan is asking, do I feed in the token letters or numbers? I'm not really sure what you mean by that, but when you're working with an LLM, you're feeding it your input in natural language. So in English, Swahili, Korean, that is what you're giving the model. But then in the background, the tokenization, the embedding, those are processes that happen in the background before your input actually hits the language model. So if you could try and rephrase the question, in case I've not answered it, that would be really, really useful. All right, so I think with that, we will get into the last concept that we'll look at today, which is RAG, Retrieval Augmented Generation. So remember, the key thing that we're trying to solve here with this approach is that we want to ensure that the system we're building can be able to access your internal documentation or just relevant information or documentation that you have, which contains the answers that your users are looking for, okay? And so with that, let's just start by a quick definition of what RAG is. And I will start this by just walking through the full workflow, how it works, and then we're going to break it down into the individual components. So this pattern, retrieval augmented generation, comprises of two components. We have a retriever and we have a generator, okay? And basically what happens is, when a user interfaces with your solution, they're going to ask a question, all right? This question is going to be picked by the retriever, and then this retriever is going to perform a quick search into the knowledge base. So based on the question that this user is asking, it's going to perform a search, and then it's going to return the relevant document or the relevant block of information that is likely going to contain the answer that this user is looking for, okay? Then up to that point, this retriever is now going to pass in the original question from the user alongside with this relevant document, and then it's going to basically tell the LLM, answer this question based on this information. And the LLM is going to do that, and the final output is going to be sent back to the user. This is the typical workflow of a RAG system, but now we're going to break it down and exactly see how these steps actually work and how you can get to implement this. If you feel like this is a little bit too much, the beauty of this is that GitHub and Microsoft have worked really hard to ensure that most of these steps are actually provided out of the box, in that you don't have to configure all these. Just worry about designing your system, granting it access, and then all these will actually happen behind the scenes, and you're going to see this momentarily. So you can now think about how do you get to build that pattern. The first thing you do is, before you even launch your system, you build the knowledge base. This knowledge base is basically the data that you want this particular LLM to reference as it's giving answers to your users. So how this happens basically is you take in your data. It doesn't have to be text because most of these models are now multimodal. That means they can take in text, images, audio, basically data in multiple formats. So you take in your data, and then you basically pass that through an embedding model. When we were talking about tokenization, we talked about how text is converted into its numerical format. So just how we have the GPT models that can give you, text completions, we now have a set of models called embedding models, whose work is to just take in data and convert that into its vector representation. And so this is the first step that you're going to be taking to build that internal knowledge base that the LLM can understand. So once you do that, you take in your data. So this could be your internal documents. This could be some confidential information that you have. Pass that through an embedding model. It will get converted into its vector representation. And then both the text and the vector will be stored in what we are calling a vector database. So when you're working with Gen AI applications, you cannot use the normal DBs that we're used to using, but rather you need to work with a database that supports storing data alongside with its vector representation. Why is this so? You need to have this data in a medium that the LLM can understand. This is the first step that you take. You build the knowledge base. And then the other things that you're going to do is basically design the retrieval and the prompt augmentation step. So what am I talking about here? So when a user comes into your system, so remember how we talked about the workflow? When a user comes into the system, they're going to ask a question. So assume I just come on your system, I'm going to ask my question, which is the user query. And then this user query is also going to be passed through the same embedding model that you used to create your database. Okay? That's a pretty key thing to point out, that you basically use the same embedding model that you use to create your knowledge base to ensure that you at least give the model some familiar, tokens, and it will be able to understand these user queries that I'm sending in. So at this point, I've come in with my question. My question is going to go through the embedding model. It's going to be converted into its vector representation. And then from this, the next step is that the retriever will actually perform a quick search. So it's going to look at this vector, this new vector for the user query, and then it's going to look through the knowledge base that you created. And then as a result, it's going to output a block of information, which is not really the answer that the user is looking for, but rather a block of information that is likely going to contain the answer that the user is looking for. Okay, I'll repeat that. So as a user, I come in, I pass in my user query, that goes through the embedding model. It will be converted into its vector representation. And then that vector representation is going to be used to trigger a search, and it's going to look for anything that is close to these vectors. So it's going to return the top n result. So you can define if you want it to, return like a 1,500 block of information. And then basically what this is going to do is that it's going to augment the initial prompt that I gave the system. So right here, if I ask the question, what is Azure? And then I want it to answer this particular question based on this information, I'm now going to augment the final prompt that will go into my system. So the prompt that I give it is going to be sent to the model. And in addition to that, it's also going to send in this particular information that it has grabbed from the knowledge base. So that's the typical workflow of how a RAG pattern works. And to just show this a bit, I'm going to go back to GitHub models. So again, this is a feature in preview. Let me try and refresh here. But yeah, if you can have a chance to apply for the preview, that would be really nice. But as you can see, we're working with the same model, OpenAI GPT-4 model. So we have the normal parameters that you set, but now we have this new feature. As I mentioned, it's still in preview, so you may still not have access to it. And yeah, this morning there's something that wasn't working, but I'll explain that later. But say, for instance, I want to ask a question like, what is the refund policy? Right? If I ask such a question, it's going to basically just give me a generic question, a generic response, right? It's not grounded on any data. But what if I have a set of documents? So in this case, I have the terms of service, which actually includes the refund policy, right? So in this particular document, I want to build a knowledge base from this document, this PDF file that I'm looking at. So back here on GitHub models, we have this option to upload files to create an index. And this is what I was talking about. So you can come in, you can choose your file. I'm going to select, I should have it here, terms of service. And once I upload that, it's basically going to perform that tokenization and vectorization step. So it's going to take in the information from that particular PDF file. It is going to split it into tokens, and then it's also going to convert that into vectors. And you can see here, we have the process that is still ongoing. So it's creating an index of vectors that will be used to now reference, and you can actually choose to answer the user question based on this particular data. So as you can see now, this has been completed. But unfortunately, and this is something that I just raised today, as I mentioned, this is still in preview, so we still have some bugs. One of the bugs is that right now you cannot enable GitHub models to use this index. So if I were to ask this same question again, ideally what should happen is that it should give me the refund policy based on the Contoso Real Estate organization. But unfortunately, I will not be able to show that because I cannot select this box. But if that were possible, you just select that, clear the chat, ask the question again, and it's going to give you an answer based on that information. But just to cover that, I'm going to go on my VS Code. So I have a demo that you can actually run, and I can ask the moderators to drop the demo, the Ask YouTube demo. So this is basically a demo that you can use. You can run this locally, or you can choose to deploy on Azure, whichever you decide to do. But for this demo, basically is I want to use RAG to ask questions about a specific video on YouTube. So in most cases, you find that you have some YouTube videos that are 1 hour plus long, and you just want to quickly get some insights around what that video was all about. So in this case, I have the code running here. We are not going to publish anything on Azure simply because there is this tool called Ollama. So we have Ollama, which is a tool that allows you to download some models and you can run them fully on your computer. So this is the approach that I'm going to use. If you want to run and try out this sample on your own, I believe the link should be dropped in the chat. Have a look at the sample. It has some very clear instructions on how to get started. We have the sample code already prepared for you. So you'll come in, you will just do a quick npm install. You will pull in the specific models that you want to work with. So I did this before just to save on time. So I'm using Llama 3. So I'm going to use Llama 3 as the language model, and then I'm going to use all mini LM as the embedding model. You'll see this in the code shortly. And then just to show how this works, I'm going to copy this, paste that on the terminal. But before I run it, let's try and understand what's happening here. So in the code, I'm actually passing in a link to a YouTube video. And this is actually the first video of this training series. So for those who attended that presentation or that session, you can be able to validate whether the data that we get or the information that we get from this model is accurate. If it's not accurate, please tell me in the chat, and we will definitely know something is wrong here, or I am flat out lying to you. So this is a link to the YouTube video. It's one of the videos in this series. And the question that we're asking is, who are the presenters in this video? So I'm going to run that. I'll hit enter. So I already have Olama running locally, so it's online. So you can see it's taking a few steps. So it's going to initialize my model. It's going to initialize my vector database. It will embed the document. I will explain shortly what this is all about. And then it's going to run the chain. And what I expect is that it's going to give me answers based on the content of the YouTube transcript. So in this case, it comes back and it tells me the presenters mentioned in this video are Maran Hussein, I believe that should be Marjan, Farah, and Bethany. And if you are there on that particular call, you can let us know if this is accurate. Then we can basically just change this question. Let's ask a question like, what was the presentation about, for example? So what was the presentation about? And then I'm just going to run, I won't change anything else. I'm going to rerun the same command, and then we'll give it a few seconds. It's going to do some stuff in the background, and then it will tell us the presentation was about Microsoft AI services, specifically Azure AI platform. Again, if you're on the call, please let us know if this is accurate. So just to quickly walk through what is happening here. First thing that we are doing is that we're passing in the data. We want to ground this LLM. I don't want it to give me any presentation about anything. I want it to base its answer based on the data that I will give it. The data that I'm giving it in real sense is the transcript of the YouTube video. So I'll pass in the YouTube video, and then I'm going to load in the video, and I'm going to use this loader to fetch the transcript. And then I'm going to store that transcript in the raw documents variable here. And then we're going to split this particular document. So remember, we're working with a document. We want to split it and then convert that into its vector representation. So now we're telling it, I want you to split this transcript into blocks of 1,500 chunks each. And then because we also want to retain the, like the flow of information, I want you to have a 200 token overlap. So before you split the next 1,500 tokens, I want you to just bite 200 from the previous token, just to ensure that we have some continuity in these chunks. And then we're going to split that. Again, you don't have to define all these methods from scratch. As you can see at the very top, we're importing some methods from LangChain. We're not going to talk about that, but this is a framework that really simplifies the process of building Gen AI applications. I invite you to read more about these frameworks. But then we're doing that splitting, and then we're storing that in documents. Then the next thing we're doing is that we're initializing our model and our local vector DB. As I said, we are using models that are running locally on my computer. So I'm using all mini-LM as the embeddings model to convert the transcripts into vectors. And then I'm going to use Chatolama for that chat experience. So we're going to embed these documents, and then we're basically now just going to put everything together. So we are telling it, this is the system prompt that we are passing to the model. It's very basic. Answer the questions only using the sources below. And this context is basically the retriever. As we talked about on the slide, the retriever being invoked by the user question. It's going to search through the transcript, look for something that is similar to what I am asking, and then it's basically just going to print out the result. So that's how you can simply implement this. This is in JavaScript, but the beauty of GitHub models is if you test how this works right here on the playground, and you now want to migrate this to your code, you can switch over to the codes tab. And right here, you actually have some sample code in different languages. So Python, C#, JavaScript, Java, and Rust. And you can easily now be able to convert this into an application and run this using your preferred language. So I hope that makes sense so far. And for this particular demo that I wasn't able to use, so I went on and deployed a certain version of of another sample that basically implements RAG in the background. So as you can see, this is the typical UI that you would interface with when you're working with chat applications. So I'm going to ask it what the refund policy is. Normally, you would get a generic question, but since this sample also implements RAG, I have fed it the same document that I was showing you earlier. And if this process decides to finish today, you're going to see that it's going to reference specifically the refund policy at Contoso Real Estate. And as we passed on in the system message, I'm telling it to ensure that it cites where it got this information from. And so again, this is a different sample. So if you click on this, you'll be able to see exactly where it got this particular answer. So that's a quick way of reassuring your users that they're getting accurate responses and that they're getting factual answers from the systems. So again, if you want to also play around with this sample, deploy it, get to see how it has been put together, we also have that as a sample, open source sample. It's called Serverless AI Chat with RAG using LangChain.js. So you can simply just go through the code base. It has the instructions on how you can set it up, run this locally, run this by deploying it on Azure. And the moderators can also share this link with you on the chat. I see we have only 4 minutes remaining. The last bit I was to cover was on the multi-modality capabilities of these models. So far, we've seen that we're just interacting with these models using chat, right? So text in, text out. But what if I were to give this model an image, right? So I'm going to give it an image, and I can ask a question like, describe the content of this image. So this model is very powerful. So it's not able to just process text. It can take in data in different formats. So in this case, I've given it an image, and I expect it to actually scan through the image and then tell me exactly what's in this image. So it's going to give me some information. So it's telling me it contains a hand-drawn catalog for Contoso Outdoor Company, blah, blah, blah. If you want to verify that, I can quickly just open it here. And as you can see, it's fairly accurate. The next thing you might want to try is, say someone just gave you this sketch and they were like, hey, can you implement a quick prototype for me? So what you can actually do is come in and you can just ask this model to generate some CSS and HTML code that will implement that draft or that design. This can easily save you some time because it was able to accurately interact with the image, extract what it's all about, and then what I expect now is for it to actually give me some, boilerplate code that I can use to actually just come up with a quick single-page website for this particular for this particular company. So in this case, we'll see it drafted some HTML code. I have no way of testing this. It separated the CSS code. You can see the CSS code is not complete, or there appears to be some buffering here. But yeah, I'm actually surprised that it chose to split HTML and CSS, so that's pretty impressive. At present, there's no way to test this out on the playground. So maybe what you can do is switch over to VS Code. Again, I'm trying to rush in the interest of time. But again, this is something you can easily try on your own. But then I'm just going to paste in exactly what it gave me. And I see we have something that kind of makes sense. It's not exactly what this page is about, but I think it's because I'm yet to add in the CSS code that it gave me. Looks like it completed everything. It was a bit slow. I think it's my machine. And then I'm just going to copy the CSS, maybe paste that, maybe paste that in a CSS file. And then see if we're linking it here. So it's going to reference styles.css. My file is called style.css. And again, in a matter of less than 5 minutes, I was able to move from just an idea, a prototype. And if someone just wanted to see how this would look like, again, think of it as a very quick way. I love the use of emojis here, to be honest, guys. And this is the first time I'm seeing it do this, but yeah, this is just like a quick way for you to actually get these models to help you with some of the tasks that would otherwise take you a bit longer to achieve. So with that, I know we are at time. Let me see if we can scan through some questions. Bethany, if you have any pressing questions, we can tackle them before we wind up.
Yeah, I think the only question was around vector databases. Is it possible? Let me look for that question. Azure has no. I think I've lost it. Maybe you can check in the chat. But it was around if you can be able to add in any other vector databases on Azure.
Yeah,
Yeah.
great question. So far, I think you guys noticed that I was just working with local models and GitHub models. That was intentional because part 2 of this presentation will now focus on this exact experience, but working with these models from Azure. And from there, you can actually see how you can use multiple or different vector databases. You can choose to use Azure AI Search, or now come in and use existing databases like Postgres that have specific extensions to support your vector data. So I think that will be covered more in depth in part 2 of this presentation.
Okay. Thank you so much for your presentation, Julia. It's always wonderful to see you here. And it was an amazing session as well. I've learned a lot. I have dealt with generative AI for a while and I've learned a lot. That means something, right? Thank you so much. And as we wrap up, the key call to action is 2 things. One, you can go check out our blog post for any details you need to know about the series. And next week, Tuesday, same time, we're having a session deep diving now on how you can build generative AI applications on Azure AI Foundry. So be sure to join me then. I'll be the one doing the session. So join me then and we can learn together as well. Thank you so much and have a great day,
But,
evening, night, from wherever you
so,
are.
all right, Bethany, just one last call out
Yeah.
before we move. So if you're interested in all the resources that I've used for today's presentation, so the deck, the videos, we have this repository. It's actually a new course built by my team, Generative AI with JavaScript. If you land on this repository, and I believe the link will also be shared, you'll be able to access every single presentation, demo, and even the scripts and the PowerPoints that I've actually used today. So if you want to learn more, you'll actually dive into other concepts. You can have a look at this repo. If you love to learn in video format, we also have a playlist that is just a representation of that repository that I've talked to you about. So all this will be shared on the chat, and I believe that we also have a Discord channel in case you have any further questions. And please, this is an amazing resource that you can have a look at, go through it, and it will just basically help you understand these concepts better. That's
Thank you.
it.
Thank you so much, Julia.
Thank you.
Bye, everyone. See you next week.
All right, bye.